We are going to be talking about THC-A.
Diamonds
and sauce.
Terp sauce.
That's pretty sweet. Yeah. So we're going to be talking about that today. But before we get started, we would love you to visit our website and take advantage of all of our website materials. We have tremendous amount of materials. We have calculators, we have podcasts, we have downloadable guides, and most importantly, of course, we have a little bot on there.
Yep.
And you go to the bot, and it'll give you pricing, pricing ranges, and then it'll also set up a meeting with one of our guys to go over details. The resources that we have on the website are only partial resources. When you get in contact with one of our sales engineers, they can really, really help you out with real data, sit down, walk through the process, and really help you craft a value proposition for your organization. So
I like to call them sales extractioneers.
Extractioneers.
Right?
Yes.
Because they understand the process.
Exactly. So if you want a subject matter expert, basically give us a buzz. And so with that, I think we can get started. So let's talk about diamonds, THC diamonds. What are they?
It's just a pure version of THC-A, right?
Yeah.
The terpenes have essentially been removed or separated, and you are looking at a THC crystal or THC-A crystal that's essentially precipitated out of the original matrix.
Yeah, and those THC-A molecules and crystals, they're acidic in nature, right? So you wouldn't want to decarboxylate anything because you probably
then it's gone.
They would be gone,
no
right?
More crystals.
So you got to keep it nice and cool,
Yep.
So that you're not decarboxylating. How do people typically make THC diamonds?
Well, first, I think it's important to understand it was accidentally discovered, just like everything else in our industry. It was found through hydrocarbon extraction, right? So a lot of times in the beginning, they weren't purging.
All those beautiful diamonds in the purge ovens. And,
yeah, exactly, right? They weren't purging the hydrocarbon extraction enough, and there was residual amounts of solvent in that extract, which would essentially be supersaturation of the solvent and precipitation out of the cannabinoids.
So that's what you get. You get this nice little waxy matrix with little diamonds, and they start to sparkle, and you're like, wow, we got to buy that stuff.
Yes.
That's because, of course, when you dab it or vape it, I guess it would then convert to decarboxylate, so it would become bioavailable under a hot instrument.
Yep.
And and then people would like that because you're getting more of a pure THC effect.
Yeah, we're
rather
talking
than
80-90%.
Yeah, it's really, really potent stuff.
Extremely potent.
Right? So, so there's a lot of different ways. I mean, obviously butane was how it was discovered. Of course, not everybody in the world uses butane, but certainly butane is probably the number one way to make THC diamonds and wax. When they talk about diamonds and wax or wax diamonds, what are they really talking about there? Usually you want to get rid of the wax, right, with winterization.
Yeah, it's different, right? It's weird.
No, everybody wants to smoke the wax. Unless it's CO2, then they want to get rid of the wax. So,
I think the main thing is the lipid removal during the winterization process is what's crucial, is what people are looking to remove because of that flavor profile is still attached if the lipids are there. So if we're making a wax, and keep in mind that wax, sugar, shatter, they're all essentially the same product, right? Just a tweak on the post-processing to give you the viscosity you're looking for.
Right. But then what is sugar then?
So sugar is essentially nucleated cannabinoids and terpenes, right? So that crystallization process is just starting, but it's more of a natural process because the terpenes that are there are acting as that solvent.
So it's just basically getting a little bit cloudy. It's getting a little bit cloudy. You can just start to see the nucleation. You can start to see the precipitation. You're like, oh, I gotta let it sit a little bit a while.
Just a little longer
for those diamonds to start forming. So. All right, so that's one way to do it. We also know that you can do this in CO2, which is kind of great because if you are able to really do it in CO2, you can basically eliminate butane and propane or mixed butane propane. That has advantages, obviously, operationally.
For sure.
And then also if you're doing GMP, it's a little bit better way and easier to scale the CO2. So a lot of different benefits that come with that. That's why people wanted to do it. So some of the key methods there. Why don't you talk a little bit about that?
Well, it's the process behind it is the same, right? That super saturation with a solvent into your cannabinoids,
right,
and it precipitates out over
right.
time. I started as a hydrocarbon guy. I thought that there was no better extract on the planet compared to when you're using propane butane blends. And then I learned how to use liquid CO2 properly. Once I learned how to use CO2, and I was like, oh, we can do the same stuff. Might take a little longer, but
right.
it's a cleaner process. It changed everything for me.
Right.
Everything. So it's just a matter of putting that extract in a pressurized vessel that allows that liquid to stay liquid and build pressure and to form diamonds, because diamonds form under pressure.
On our podcast, we promote, decarbing the biomass. You wouldn't want to do that in this case. You would want to start with a dry biomass, obviously, sometime right around 5% maximum of water, and then you would basically start extracting at low pressures.
Yep.
That really would allow you to start to slowly extract. So if you do diamond extraction with a CO2, your methods are going to be a lot longer in length. Okay, it's not going to be like move the pressure way up to 5,000 psi,
right.
extract quickly 100% or 95% of the cannabinoids. No, it's actually going to take you a lot longer. Yes. And then a lot of people run their collectors at a much higher temperature. So they'll run them at almost up to 70 degrees plus.
Yep.
And what that does, I think, is that it basically takes the CO2 and expands the CO2 so that it pushes basically the crystals right out of solution. So a lot of people do that. As a method. So that's how you would make the diamonds. And of course the wax would come out, even at low pressures, waxes come out. So you would then have just a waxy diamond filled,
they separate
stuff
inside the collection vessel. So
right.
that waxy terpene content
right.
would essentially go to that bottom of that collection vessel.
Right.
And the diamonds or crystals would sit inside that sauce
right.
or on the walls of that vessel.
Right. So yeah, exactly. So it would be on the walls of the vessel, and you'd have to kind of scrape it down. So it's a really important point that you make there is that, they do stick to the walls, and it's kind of a pain to get it off. So you gotta have like a little tool where you push it down. You have like a container underneath that's a catch pot, right? And you push it down, and it'll scrape the side of the walls.
Like a chimney sweep.
Yeah, like a little chimney sweep. So those are the things. But you can certainly do that with a CO2 machine. And a lot of people like that because it's not a big market, right? Because,
very small.
Yeah. But a lot of it is just street credibility. Hey, look at these diamonds that I made. They're great for Instagram, for example.
Well, it comes with the culture that is cannabis, right?
Yeah. And so if you want to make pure THC diamonds or you want to make diamond wax, go ahead and try it in your CO2. If you haven't tried it yet, you should at least try it once, right?
Absolutely.
You have typically your extractor sitting, idle overnight. You should be using that time, right? To, go ahead and start extracting some acids and see what you come up with, right?
Absolutely.
So timing wise, I think you're looking at, 5 to 6 or 7 hours. Okay. So you try to go as low a pressure as possible. So 1,000 to 2,000 PSI, something like that.
I like to go a little lower than that, right?
Okay.
So
600?
the idea is you want to mimic cryo environments, right? So you try to mimic that extraction band of hydrocarbons. If you can run down 300-400 PSI, it's beautiful.
Okay.
If you can't and you're maxing out 800 to 1,000, still doable.
Right.
Still doable. It's actually going to take you less time at those pressures.
Right.
However, your product isn't going to form as much as a pure diamond.
Right. So what you need in order to make that happen, probably what you would need is you'd need to have a low temperature. So you're talking about on your exchanger going into your unit, you're going to have to go down to minus 15, minus 20 in order to do that. And then also you're probably going to not want to post heat to bring it up into the typically after the extractor, you would heat it up to get it into the supercritical region. You wouldn't do that. This is a true subcritical separation. Right. So, there you go. There you have it. That's how you make THC diamonds and wax. And, it's kind of a good street credibility thing.
Absolutely.
And you're going to be able to mount those crystals, get some nice backlighting behind them, maybe get some UV lighting behind them, and and make them look really awesome, right?
I think the key thing is also like you have one system capable of producing essentially all of the concentrate products that are available on the market.
Right.
You don't need to go to ethanol for this extract. You don't need to go to hydrocarbons for this extract or CO2 for this extract.
Right.
If you utilize CO2 with all of its potential and capabilities, you can really make every product available on the market.
Yeah, that's a really good point. I mean, you really need to think about the versatility in the equipment that you're buying, right?
Absolutely.
So, yeah, and I think it's less common to see, for example, THC-A diamonds coming out of a CO2 extractor. It's not that it can't be done. It's just people haven't done it, right? I mean, in a lot of, it hasn't been well known.
Right. Well, you stick with what you know. We know hydrocarbon works really well for it, so that's what they target.
Some of our major clients, that's what they do, you know, that are doing that in a GMP environment.
Yep.
So you can, what's nice about that is you don't have to worry about explosion proof, ATEX considerations, classified rooms, things like that.
Solvent storage capable, like all of that becomes null.
Becomes a null factor, and you can just basically do them in your extractor. So one thing that we didn't touch on was terpenes and the role of terpenes in the THC diamond process and precipitation process. What's been your experience on terpenes?
So the higher the terpene content, the better crash or precipitation you're going to get. It essentially acts as supercharging that solvent, or acts as a co-solvent almost, that gives it that little extra oomph to kind of separate a little quicker.
Right. Yeah, so basically, you may even want to, if you have some crystals that you want to make out of THC and you don't have very good terpene profile, you may have a hard time getting those crystals to form. Yep. So just keep that in mind. There are some other co-solvents that actually are in the plant itself that will help precipitate out the acids. So. All right. Well, thanks for joining us. I appreciate your time. And this has been us for Extract Talks. You guys take care. Bye now.
Take care.